Right. So good stuff. So do you hear me okay? Good. Yeah, so I'm just going to share my screen now and disconnect the camera. So you should be able to see my screen okay. Good stuff. So yeah, it's great to be speaking and presenting. I'm actually in Stockholm, Sweden. It's a cold sort of autumn day here, just after lunchtime as well. So it's good to be able to, reach around the world and
Presenting.
to
I'm
be able to,
actually in
communicate
Stockholm,
with
Sweden.
It's a cold sort of autumn
So a
day
bit
here,
about myself.
just
My
after
name's
lunchtime
Alan
as well.
Smith.
So it's good to be able to,
Describe
reach
myself as
around the world and to be
presenting.
able
I'm
to,
actually in
communicate with
Stockholm, Sweden.
It's a cold sort of autumn
I've been
day
a bit
here,
about myself.
just
My
after
name's
lunchtime
Alan
as well.
Smith.
So it's good to be able to.
As a BizTalk server, and then got into connected systems developer, and then into Microsoft at Azure. So I've been focusing all the time looking at emerging technologies. I involve myself a lot with the community, so I've been involved with things like the Global Azure Bootcamp, the Global AI Bootcamp, also a couple of conferences that we've been running in Stockholm, the Cloud Burst Conference and the AI Burst Conference. I've been involved in working with those, and also getting around to as many conferences as I can get away with, visiting and presenting at. So I'm going to talk a bit about the theory on reinforcement learning, and then Eve's going to basically be showing us some of the great exciting technology that we've got that Microsoft has developed that allows us to start using this technology in a cloud-based environment. So, what differs reinforcement learning from traditional learning is with traditional machine learning, we typically work with large data sets. If you've looked at doing something like image classification or predicting house prices, apartment prices, you typically start with a huge data set, and this basically has all of the answers that you need for all of the various samples. So you'll have 1,000 photos of cats, 1,000 photos of dogs, and you can build a classifier that can take photos and unknown photos and classify them as cats or dogs. Or you've got loads of data on apartment prices and various factors such as the size, the location, the age of the house that will affect the apartment price. And you can build or train a model to be able to come out with those predictions. With reinforcement learning, we don't have the answers. We don't have any sample data. Though what we do have is an environment that we can send agents into to basically explore this environment and be able to figure out and learn a bit about this environment. So we start with an environment. We'll talk about how we interface with an environment a bit later on. The environment basically has a state, and we'll discuss basically what the states are. But this basically describes things about the particular environment. And what we do is we basically take an action, and we basically put in an action into the environment, and that will basically result in the states changing. So we're working with agents, and the agent is going to be responsible for basically reading the state of the environment, looking at the state of the environment and making a decision, and then basically putting an action into the environment and getting out some kind of a reward. So typically, starting out, the environment is completely explored. I kind of think it's a bit similar to you go shopping. There's the regular supermarket you normally go to, but one thing you can go to a new supermarket and you go into a new supermarket, you don't know where everything is. So you basically have to explore that environment. It takes you a long time to do your shopping the first time, but then you basically gain an understanding of that environment and learn your way to how to navigate around that environment. So that's kind of these scenarios that we are looking at there. And the reward is going to be guiding the agent as to whether the action it took was a good action or a bad action. So we can look at some examples of this and how the state of an environment can run. So sometimes the states can be taken from some kind of physical model. This is actually, Lunar Lander. I remember playing Lunar Lander when I was probably about 7 or 8 years old. So this must have been about 42 years ago on a green screen computer that was a huge computer with this green screen and a light pen on. And it was the first computer game I ever saw.
So basically, within the Lunar Lander, building an agent that can understand the state. These are all going to be, numbers that are coming from some kind of physical environment. We've got the altitude, the horizontal speed, the vertical speed, the amount of fuel that we've got left, and then we'll have, readings like the height above the ground and various information on the ground mapping. And based on this data, we can build a model that's going to give some kind of action as to what we do in the Lunar Lander game. Another example, and this has been a fairly common machine learning scenario, is working with the Atari Games. We could never afford one of these Atari consoles, so I must have been about 11, 12 years old. So this must have been about in the 70s sometime, late 70s, early 80s, when you had these Atari consoles. And you could basically plug in the Space Invaders cartridge or the Pac-Man cartridge. And the games were pretty low resolution. They were all, mostly 2D graphics. And in this case, when they're looking at the actual state, the state is basically, the actual pixels on the screen. There's not that many pixels. It's quite low resolution. The pixels are quite descriptive of what's going on the screen. So when we're looking at these Atari game simulations, they've had a lot of success in being able to build an artificial intelligence where the input to the model is basically the screen. The output is going to be, how to move the actual controller, and the reward is going to be something like the actual score of the game. So you can get, quite good results in that scenario. As games get more complex, it becomes a lot more challenging to be able to understand the actual, pixels on the screen and how they relate to reality. We're also getting a much more real-world description of, how the actual environment looks. And thing I think is really cool about looking about building AIs for driving games is we're getting into the territory where you've got companies like Tesla who are evolving this technology, and many of the automobile manufacturers. How do you take an input like that, a bitmap like that, and how do you basically interpret and figure out, what action you've got to take based on that particular state? I'll show you some video of some AIs that are learning to drive. This is actually one of the Forza games, and it's on the actual. If you've ever seen the TV program Top Gear, the British TV program, this is the actual Top Gear test track that they're using as a track, and they got quite a bit of success from this by actually processing the bitmap images. So what my model was going to be processing was not the actual screenshot from the car, because this is kind of complex. You've got, the sun reflecting, you've got, the actual car that you're driving. You also need to know that the road is not going straight on. The road is actually going round to the left. So we need to make a left turn here. And you can tell that because of these cones that are in the way, and also because of this driver's line. So what I did was I basically wrote code that will basically filter out. So it takes the actual bitmap image. We flip the bitmap image so we've kind of got more of a top-down image. We kind of do a translation on the image. And then we're doing quite a precise color filter. Well, we're taking the colors in the actual racing line, which is displayed here. And we're basically filtering out those colors. Everything else is going to be black, apart from these colors on the racing line with a certain amount of tolerance, and they're going to be white. And what I'm doing here is basically feeding the model a much clearer representation of the game state than the actual image itself, and it allows the model to have a much better signal to noise ratio, and it's able to understand this image a lot better. So based on this particular driving line, the model is able to basically learn how to drive around the actual track. Other scenarios that we can look at is using neural networks to be able to do things like image classification. So here, this isn't reinforcement learning to be able to build a model like this. I'm using the Azure computer vision service to be able to take the actual screenshot, send that into the computer vision service, and just basically tell me whereabouts the cars are. So it's able to detect. It's a very simple model. I've just trained this model to detect cars in the Forza games. So it's kind of detecting Lamborghinis and Ferraris and Aston Martins and all these types of things. And it basically gives the position of the cars that it's detecting. And that means that we can, use that with the actual driver AI to be able to actually, figure out what path to take. And then we get onto the actions. Well, dependent on the actual game that we're using, the action can be different. Some games are, controlled by the keyboard. Pressing a certain key will perform a certain action. With the Atari games, we've got a joystick controller where you've got left, right, up, down, and fire. That's pretty much all of the actions that we can take in the Atari games. And then with the driving games, we've got a steering wheel where we're basically doing, 0 is a straight line, and then you've got positive and you've got negative. You've also got the accelerator and the brakes, which you're going to be controlling as well. So these are basically the actions. Then it comes to the reward. How do you basically judge one model as being better than another model? So in my case, with Forza, I basically said, well, the reward is going to be how far you've driven. If you've basically stayed on the track for 145.34 meters, that's an actual score. And you can say that if you stay on the track for 150 meters, that's going to be a better score. That's going to be an improvement. So it can use these rewards to basically govern and be able to actually learn which is the best action to take based on a given state. With the rockets, I looked at a scenario where landing the rocket is successful, crashing the rocket is going to be something that's unsuccessful. But we kind of want to have a kind of numeric value. So what I basically said was the actual lowest landing speed of the rocket is going to be the best reward. So if you land at a very, very low velocity, then that's going to be the best reward. So it's kind of like a negative thing. If you land at a high velocity, that's a bad thing. So crashing very fast is worse than crashing fairly slowly, even if you do destroy the rocket. So what we're doing is we're aiming to actually evolve the model so that the landing speed of the rocket is going to be as slow as possible. And as I mentioned with the Atari games, often there's a decimal score. So getting 2,500 points is better than getting 362 points. So based on the score, we can focus on that evolving to get the highest score. So we're going to look at a couple of examples of those that I've implemented using code, and I'll start out with the driving game example. So I used to be a physics geek at school, so I used to love working with mass and friction and weight and torque and energy and all types of things like this. So I basically started just for fun coding up a 2D driving model, and this basically 2D simulator basically had its own sort of vehicle physics in there. And what I've done is basically taken this 2D car, and I've got some evolution running on this. I'm going to restart this again because it did evolve fairly quickly. Normally it doesn't do that. What we do is our environment is basically the track that we are running around. The agents that are going in are these cars, and I think I've got like 20 or 50 of these in each particular generation. And all of these cars basically have the aim of driving as far as they can around this track. And if they leave the track, if they crash, then the agent dies. And the actual score that we're getting, you can see in the generations. The first generation got 456 pixels. The next generation 4 pixels. The first generation got 456 pixels. The next what we see here is the actual neural network that's powering the cars. We're taking inputs, and these inputs are distance sensors. So if you imagine my hand like this, we've got distance sensors going out perpendicular at 90 degrees, distance sensors at 45 degrees, and one going out straight forward. We feed in the distance sensors to the neural network, and it makes decisions about whether it should drive left or whether it should drive right, and the actual throttle that it's going to be making. So now on generation 4, it's kind of looking like it's got successfully most of the way around the track. So it didn't take long to actually learn and evolve. And the way this works is we're combining a neural network with something called a genetic algorithm. We basically start off, if I click on this, we start out with like 50 of these cars. And the one that performs the best, we basically use the genes or the weights in the neural network to actually form the next generation. And we use mutation and crossbreeding to actually combine, the top genes, the top performers, to be able to, produce better performance. So now you can see that the whole population is evolving. We've got 4 cars that are actually able to make it successfully around the track again. So that's a very, very simple scenario. Things got a bit more complex, as you can imagine, when we tried to get the AI to play Forza. So this, if I just bring up this
browser tab here. Let's see if I can run this. So what happened here was, the first generation of this. I'm not putting in the generation numbers, but this is the first generation that couldn't drive. And then I skipped forward a few generations, and it basically learnt that keeping the wheels straight when the track is straight is a good thing to do. Then the track turns right, and the car decided to turn left, and that was a bad idea. But you can see it is basically evolving, and it is hopefully getting better at performing this. If I can refresh this. And it does basically learn eventually that the correct direction to steer. And what I'm doing is basically advancing, through quite a few generations. This thing was running for about 1.5 days, I think, to be able to evolve this far. One of the challenges with this model is that we couldn't run, 50 consecutive cars. So each generation, I think I had about 20 in each generation. You'd have to play the game 20 times and basically crash 20 times, crash off the road 20 times just to run one generation. So it took it a long time to figure things out. It's also not too good on tyres. If you've got a Lamborghini Aventador, I think that this is this, or is it a Lamborghini Huracan? But it's going to be pretty expensive on tyres, and it seems to just understands that full left and full right is the way to steer a Lamborghini. So you can see big clouds of smoke appearing whenever it's making a change in the steering. So it's getting there, but I could never get it to go around that sort of first major corner there. It was a very very challenging scenario. At least I found it quite challenging to actually build this and get this to actually evolve and learn. The technology I was using was something called Sharp Neat, which is a neat. It stands for neurological evolution with augmented topologies, I think. And there is a C# build on that that's available. So that's basically what that thing is using. I also, if you've attended the Global AI Bootcamp or the Global Azure Bootcamps, we've had a racing game. And I basically implemented the same technique as in the 2D racing game in the actual racing game in the Global AI Bootcamp. Sometimes you get strange scenarios. This is a scenario where the car was basically evolving and discovering something called a false minimum. So sometimes an AI will discover a really strange way of being able to actually solve a particular problem. So in this scenario, when I ran, the first few generations, the most successful model basically thought that driving the car backwards achieved the highest distance. So the highest reward was for basically turning around and driving backwards and then crashing into the barrier. So it decided that driving backwards was a good idea, and all of the future generations basically evolved on the car driving backwards. It can drive pretty fast. It's doing 100 miles an hour backwards, but the car could do about 280 miles an hour forwards. So this is basically something called a false minimum, where it basically learns the wrong way to solve a particular problem. And there's some good examples of that, some funny examples if we look at and start to study machine learning. You will hit these problems. They're quite amusing when you do discover these scenarios. The other scenario that I was going to talk at was the rockets, I think. Yeah, this was just basically a bit about the forza. How I'm taking the state, I'm using that as the input, which is going to be a certain variation that you make in the steering to be able to drive around the track, and I'm using that as the actual reward. A lot of the machine learning that we're doing is basically, or a lot of the problems that we're solving, it's quite challenging to understand how machines actually solve the problem. If we look at the driving game, if you've driven a car and you see a screenshot from a driving game, you know what to do in that driving game. Or if you've played one driving game, you'll know how to play another driving game. Or if you've played a driving game, you may learn to drive a car that way. And it basically makes the assumption that, as we evolve, as we learn things, as we get to be, 10, 20, 30, 40, 50 years old, we build up a lot of experience about the world around us, about the environment around us. Whereas the AIs going in don't understand anything about the environment that they're reacting with. So I can tell by looking at this screen that this is a platform game. I can tell that, this thing down here is probably going to be me. That's going to be the player. I'm probably not going to be one of these blobby things here. And then I can see that these spikes, it's probably a bad idea to jump on these spikes. It's probably a bad idea to actually, interact with this particular monster here or this particular monster here. And this thing here is a ladder that I can probably climb up, and I can probably jump around on these platforms. So you basically understand a lot by just being human. One interesting thing that the website, you can actually search and Google for this, is they basically provide the same platform game in the way that the computer may see this game. They've got no concept of what a ladder is, or what a blob is, or what an actual person is. So just understanding that these are various blocks, which block is me, which block is going to be the spikes, which block is going to be the monsters, and which color is going to be the ladder, and basically gaining an understanding like that. So it's going to be interesting to understand, that the machine is really starting with zero knowledge of the environment. It's basically learning, discovering a way to interact with the environment. The other example I'm going to look at is the landing rocket boosters. This was an early experiment that I did when I was looking at genetic algorithms. So this is actually coded up in Unity. And I was kind of inspired by Elon Musk, and I think it was the first Falcon Heavy flight that was taking place. And they were basically trying to land these rocket boosters and get the actual, landing of the rocket booster with these, things coming down on the pad. And I think the first Falcon Heavy flight, they'd actually managed to land both of these rocket boosters simultaneously, and that just, blew my mind, especially being a physics geek. How did they get that right? And this is basically using a genetic algorithm to basically discover the optimal way to land a rocket booster. So we're starting off with 25 of these things, and they all crash. And what I'm doing, one of them survived. So what we're doing here is basically trying to use the the landing speed of these rockets to be able to govern the reward. The ones that land with the slowest impact velocity with the ground, that's going to basically be used for the actual genes to govern how the actual rockets are going to behave in flight. And we can see that this is evolving through the generations. The rockets are becoming more and more successful at being able to actually land without actually exploding. And eventually, we get 25 rockets, landing simultaneously on the landing pad there. So I have no idea how I'm doing with time. We started the session a bit late, and I forgot to look at my watch when we started, unfortunately. I'm going to talk a bit about the technology that is going to be used by the Azure Machine Learning technology, and how you can start to explore that technology. It's based on something called OpenAI Gym, which is basically a toolkit that you've got for working and experimenting with machine learning algorithms. So if you want to work with reinforcement learning, there's these basic physics simulations like cart pull, where you've got to basically balance this pole on the particular cart by moving the cart left and right. So here, the state is, where the cart is, what the angle of the pole is. The action you take is the actual force that you put into the actual cart at the bottom to move it left or move it right. And the reward is the amount of time that model is able to keep the actual pole in the vertical position. If it falls more than a certain angle, then we count it as being lost game. Or if you move outside a certain bound of the track, then that's a lost game as well. You've also got these, bipeds and quadrupeds, so you can basically evolve walking robots, where the reward is going to be how far you can walk, what actual distance you can walk, and various other options like that. And then there's these various, Atari games like, the Lunar Lander game that you can actually build, taking the actual pixels from the game or the actual physics from the physics engine itself. There's a bunch of these Atari games as well. So this was all of the rage when I was about 9 or 10 years old. Space Invaders. I remember the actual original Space Invaders machines there. And you've got the options to be able to, build AIs and evolve these AIs over time to be able to win at Atari games. Now, the reason that we can use these AIs is that these environments can be plugged into or the agents can actually interface with the environments using a standard interface. So the OpenAI Gym basically defines this interface that has various options. It's got an observation space, so you can look at your actual state of the environment. You've got the action space, so you can take your actions. You've got the actual step. You can perform a certain step on this, and you've also got a render method. So if this game is a graphic game,
you can actually render a screenshot of that and basically display this as an animation. Very often when we're running these simulations, we're not going to be rendering every frame because we want to run hundreds of agents in a generation and run hundreds of generations. So that's going to be hundreds of thousands of these simulations that you're going to be running. You don't want to render all of them, but you can grab screenshots periodically, or look at how some of them are actually performing. So what this allows you to do is actually, build your own environments and build your own agents that are going to integrate with the AI. And these are typically coded in Python. There is, documentation on this, and there's some good open source examples of building your own GIM interfaces there. But you're just basically building a Python class that derives from GIM environment and provides implementations for step and reset and render and various properties for the action spaces. I'm going to hand over to Eva now, who's going to talk more about the machine learning, Azure machine learning technologies, and how we can start to experiment with the machine learning technologies within the Microsoft Azure platform.
Thank you a lot, Alan. It was a great session, so thank you. And yes, I'm going to take it over from here. I'm just going to share my screen as well. So Microsoft made an amazing history in machine learning and artificial intelligence in the past few years, as Microsoft applies machine learning to improve many of their products and services, such as for the suggestions made in Office services. And the approach of reinforcement learning in gaming became very popular in the recent years, since these game agents perform complex tasks very well thanks to reinforcement learning. These caused real breakthroughs in the field, and though there are many other use cases in the world which uses reinforcement learning, such as robotics, chemistry, education, and a lot more, the coolest thing is still the gaming situations. And remember, as Alan has told about it already, and before I go to that point, I want to quickly introduce myself as well. So I'm Eva Pardi, also an MVP, but my specialties are in data science and artificial intelligence. And if you want to learn more or hear more about these things, you're welcome to reach out to me. So the cool thing about the gaming situations is that the agents are trained under the pressure of the game. And just like as we've seen as the different situations that Alan showed us before, these agents has to understand the state of the game, where are the other entities in the game, and it has to make a decision based on this information. And Microsoft in 2020 at the Build conference has proudly announced a preview of reinforcement learning on Azure Machine Learning. And this new reinforcement learning support in Azure Machine Learning services provides scalability while training to CPU or GPU enabled virtual machines with machine learning compute clusters that can automatically provision, manage, and scale these virtual machines. And you can use different tools to build your models, just like TensorFlow, PyTorch, and other deep learning frameworks as well. And it supports Onyx as an advanced. And you can also use, as you have heard about it already, the OpenAI Gym as a gaming environment. And we can talk about single or multi-agent reinforcement learning when you are building your training scenarios. You are welcome to track your experiments and monitor all the runs that I'm going to show you in a few minutes. And because Azure provides numerous AI solutions to build, run, and grow your games, you can accelerate your games with AI and machine learning to provide more realistic worlds and challenges for your gamers. And if you would like to get started and get to have some fun with reinforcement learning in gaming, you can check out sample notebooks that you can find on the link on the bottom of this slide. And you can train an agent, for example, like this one, that has to navigate a lava maze in Minecraft. And this also uses Azure Machine Learning and single agent reinforcement learning. So the aim of the agent is to reach the blue tile while navigating through this maze by walking only on solid tiles, so only on these gray ones. And the agent might fall into the lava, in which case it has to start it over. And since the maps are generated randomly, the agent also has to learn how to generalize and adapt. Now, let's take a look into an example of how multiple agents can be trained with Azure Machine Learning in a simple gaming environment. So, Microsoft Research worked together with Ninja Theory to explore new possibilities on reinforcement learning in gaming. And the aim of the research is not to build an agent that is able to beat humans, just like, in this famous chess agent, remember that? But to provide game developers tools to make them able to apply reinforcement learning while building exciting games for their players. And so Project Paidia, that I'm going to talk about from now on, it has been announced the 3rd of August at the Games Tech Live. And the state-of-the-art artificial intelligence agents use the bleeding edge game as a research environment that I just shown you before. So in this session, we use the following situations. We have these blue circles as the agents, and they start spreading around and observe their environment while finding the landmarks. And the landmarks are those black circles. And the blue circles get rewarded if they find the landmarks without overlapping while spreading around. And we are going to use OpenAI Gem's particle environment within Azure Machine Learning Studio. So let me switch over to my demo. And to get started, all you need to have is basically an Azure Machine Learning subscription. And to get started, you should create a new resource group. Because when you put stuff into one resource group, they would communicate better with each other. And it would be a bit safer communication as well. And you can basically just click in on the add. You can give it a name, demo resource group, for example, and you can decide where to put it. You can put it to North Europe and then just create. And when the resource group is done, the next thing we need to do is to create a new workspace for Azure Machine Learning. What you need to do is to click on Create, and from the AI and Machine Learning, you choose the Machine Learning feature here. And we have to choose a resource group, and I had created one just before, and I would use this one. And we have to give it a workspace name as well. Demo workspace, for example. And you also need to choose a region. And when you try to decide what edition you want to use, you better look after what tools and services are available from the basic edition. Because if I remember correctly, the basic edition only involves the notebooks. But on the top of that, there are a lot more tools for you that you can play around with. So let me show you what you can play with. So when you have all the tools created, you just click on your workspace and say you want to launch it. And if you are new to the studio, you first have the chance to look around what you have in the studio. But when you get started, you should see this screen in front of you with the 3 different tools that you can use: the Azure Notebooks, the Automated Machine Learning, and the Designer. For those who want to write their own models with code, I suggest to use the notebooks, because with all the kind of cool compute possibilities you have, you can basically write deep learning model as well that's running inside this studio. The automated machine learning expects from you some data and some parameters, and based on this information, it's going to suggest you different models that fits best for your situations. And the designer is used for creating your own model with the drag and drop interface. And both of these models that you generate here can easily be deployed from this studio as well. So the reason why I really like this environment is because previously we also had an individual Azure notebooks, an individual studio where we could build our experiment. And now everything is at the same place. You start from like gathering the data, cleaning up the data, prepare the model, train it, evaluate the model, and then you can easily deploy from here. Now, what I wanted to show you is to go to notebooks, because this is where I'm going to spend most of the working time from now on. And what I want to show as well is this notebook. And for those who has been working with Python and has specifically used the Jupyter notebooks, might be familiar this file type called IPython notebook. This is exactly the same thing, just like that you are used to. And you can choose different computes that you can generate in the compute menu. And that's also very easy. You can just go to create a new one. We create a new demo compute. And you might want to use, oh yes. So you might want to go with a GPU and choose any of the virtual machine sizes that you are able to choose from. And when that's done, you just click create. You can start and stop the compute, and I mentioned this because I keep forgetting to stop it, and it's quite costly, so please try not to forget it. Anyway, now when I go back to my notebooks, you can see the similar folder system like you have seen before a million times probably, and what I want you to remember is that to make sure that you use the files folder that is predefined by me, and that is available also on GitHub. If you just go to my GitHub page and in the reinforcement learning branch, you can, in the repo, you can find all the files that are necessary to run these experiments. So, and you're welcome, obviously, to play with it and make changes on the code, but I will talk about that also a bit later. All right. So now I go back to my main Python code, and as you can see, first of all, I simply update my Python packages, and it's really cool that you see it's all upgrade. You don't really need to install anything actually on this notebook environment because everything is available for you already. Then I also gather the SDK version, which is also very handy in case you need to do some debugging. And it is also a good idea to define your Azure tenant that you want to use. So you can specify it with the use of the following code. And you can find the tenant information if you go to Azure and you go to tenant properties. And that's where you will find this information. Right. Then we also want to connect to this workspace that we are working with. You need to define what is the name of the workspace. You define the subscription ID and the resource group where it can be found. And if the connection is successful, you will return. You would get the name, the location, and the resource group of the workspace that is connected. By the way, this subscription information can also be found if you just go back to the portal and look at the subscriptions menu. So right, the connection was successful, and the next step is to create a new experiment. The new experiment should be a totally empty one. This will be able to show us the monitoring. So this is needed to monitor our runs. This is going to be called as EXP, and I want to put it to the workspace that is connected, and the name of it should be the multi-agent particle stuff. Yes. Right. So now we also create a new cluster, and you're welcome to use one if you have created one before. But right now, I just wanted to have a totally new one for this solution. And if there is a target already with this name, then it's going to say that there is one, so it's going to use it. Or if it is not started up, then it will return you an error message. Otherwise, it will generate new compute target for you. And here you see I'm using the standard D3, and the nodes are also defined. You can also change these configurations, but if you want to run only one experiment on this compute, it's just more than enough to use only one node for this problem. And the good thing about this cluster that is scaling down when it is not used. So you're welcome to increase the nodes if you want, really. And when the cluster is ready to use, this code would return, yes, either that it is found already or that it is the cluster is created. And then we are also going to create a customized Docker image where all the necessary software and Python packages are installed. And the configuration for the training run is defined in the environment class. And since we also want videos as results about the different runs of the particles, we need to set the interpreter path as well, where we define how big should be the video and all kind of information here. Right. So now the interesting part is coming, where we actually start the training. And for training, we are going to use the multi-agent deep deterministic policy gradient algorithm that is in short called MADDPG algorithm. And as the name suggests, it will be able to train many agents in the same time. And if the training runs over 3 hours, then it will automatically stop. Similarly, if minus 400 final reward is given. And we also have to initialize the reinforcement learning estimator with different parameters. And these parameters are necessary for all kind of estimators as well. You need to define what is the entry script, so which script should be found first and where do you find it, and what kind of parameters should be used when calling that script. And we also define the target cluster, what is the environment we are running in, so it's the Docker environment here. And just so for your information, this final reward saying minus 400, I'll show you what is the starting point basically, or what could be the starting point. The minus 400 is a pretty good result already, so that's good for us for now. If you want to make it better, then you might want to change this duration as well, because it will train a bit longer, of course. And what we also want to do is to show the run details about our little experiment. And if you go and say, I want to view the run details, you're going to be taken to the experiment straight. And you can see it is already completed. It was too quick. But if you go to child runs, you can also take a look at the logs of these runs. And if you go to outputs and logs and find this driver log txt file, I just scroll up to the beginning, and here you can see that the reward first was minus 800. And for the end of the training, after a few iterations here, it is going up to minus 400, and we stopped with minus 399. That is a good enough result already. And there are some videos as well generated, which is really cool because you can see the steps. So what happens in each iteration, how the agents behave when the training is happening. And right now you cannot really view the video inside this environment, but we can download it. And when I download it, we can already play it. And we can see the little blue things that they are trying to find their place, and this is one of the first videos, and they don't really know yet what to do. But if we find a later video, so we go ahead with time, maybe start with this one, and I just download this and want to open it up. And now they are a bit better in finding the landmarks. So evaluation of the training is very important, and it is possible to reach videos about the different iterations. And what you can also do is to easily monitor all this in live. So while the training is happening. So with the use of this code, you're basically reaching out to the videos that are generated and then read it in and try to play it. And right now we are only seeing the last video here that has been found. And since my training is not running anymore, it won't change the map. But the cool thing again about these kind of trainings is that you can give it any kind of maps. It will be able to adapt and make sure that it is using the stuff that they already learned in a new scenario as well. And another cool stuff about these tools is that you can also monitor the training run with the use of TensorBoard. And if you go to take a look at TensorBoard, you can see how our agent managed to go through on the different training iterations. And you can see all kind of calculations and graphics about how it behaves and how it improved. And again, you can do this all in runtime as well. All right. So as I have said it before, these tools are for people who really want to improve their games and want to do some cool stuff for their players. So if you want to try this out and contribute in the development of this, by the way, open source tools, you're welcome to reach out on the GitHub repos for these samples. And if you are interested, go through on other videos from this year's Build conference or some AI show with our favorite reinforcement learning developers, and read through some of the blog articles about Paidia and learn about the latest news and refreshing new information about reinforcement learning from them. And if you want to get any other help, feel free to contact me and you can reach me whenever you like. And I hope to see you next time at another event where we're probably going to present some cool new stuff with KG about reinforcement learning. So thank you a lot. That was it from me. Any questions? Do you have any questions? Hello? Okay, so maybe if it's necessary, we can share these links and where people can reach out to us. Cool. We thank you.
Hi, Setu. Can you hear me? That's good. That's good. Yeah. So let me share my screen first. Okay, so hello everyone. My name is Aro, and I'm the second speaker. And really, I love the first session from Eva and an amazing stuff they shared. Mine is a bit different. I'm only about the Power BI and how the AI visuals we can use in Power BI. Okay, so let me show what I have for you today. So about me, I'm Arush Chopra. I'm Microsoft MVP. That's a new time MVP. This got last month only, and I'm experienced in the Office 65, and I mostly experienced in Shape Online and data platform. I'm also doing some lot of consulting work in my company. I'm Microsoft partner and do a lot of trainings both for the corporates as well as for the these particular meetups, SQL group and AI groups and all. And you can contact me at my LinkedIn contact and I update my blog very regularly. And you can contact me at my Twitter handle. Okay. So again, I'll be sharing my slide deck, everything after the session. You can have a look on that. Okay, so first thing first, we see the overview of the AI, mostly specifically in the Power BI space, how it works. And today, I mostly want to deal about the all the end user visuals, how we can use in Power BI, how it works, and what are the some tricks we can use it. Then there are three demos. The first one is a key influencer visual. Second is a decomposition tree. And the last one is very, very interesting, called as a Q&A visual. Okay. All are using AI, few of the different kind of algorithm they're using. And we have a detailed demo on that, all three. Okay. So again, towards the end, we have a Q&A, and if you have any kind of question, you can ask me towards the end. Okay. And again, all the demo samples and the blog will be shared with you after the event. Okay, let's get started. Why Power BI is so interesting in terms of the in this data part. So I'm actually a data platform MVP, and I mostly specifically work on the Power BI because there's amazingly good tools which we can use it. Okay, so in terms of the Power BI specifically, there are three audience I want to target. The first one is the your data scientist. The second audience is your analyst, and the last one about demo will be on the end users. Now what's happening, the data scientists are really, they have PhD people, they have everything, they can write code and all. So they use extend the machine learning. They also integrate reports with different parts like R integration and Python. So they know all the net and bolt how the data part works. Okay, so first one, two blocks is the extend the Azure ML and the R integration. They actually deal with that. The second two blocks, which is the create ML model and the sentiment analysis, is mostly the audience is your BI professionals. Now, these people have no much information that how the algorithm is written. That particular part is handled by the data scientists. So these people are mostly have a talk to the management. They can actually using some clicks using the ML models and those kind of predictions they can do. They don't know have much knowledge about the coding part, but they know how to use the AI models using clicks. Okay, and the last part, which is we are handling it, which is the end users. These end users is very, very important because he is the driving force for any organizations, right? Maybe in the any organizations, we have 1,000 users, maybe around 800 or 900 users are end users who do drive the business. So we deal with those people now. Okay. So I just want to highlight that what is Power BI? Just 2 minutes. What Power BI does. So Power BI is actually is a business analytics service. So which you can get your data anywhere, anytime, any place. That is the beauty of Power BI. And they have three different form factors. You can use in a Power BI desktop. You can install just like your Office applications, install on your app inside your PC. Second is the cloud service, which is a Power BI service, it's a Microsoft cloud service. And the third one is something called as a Power BI mobile, right? So here you can churn your reports and show to the users using mobile devices, whether it's tablet or the mobile phones. Okay. So again, what actually Power BI desktop can do, we will work on that. How it so it mostly what does get the data from different data sources. Your data could be from your flat files, could be your Excel file, could be your SQL data, could any data you can actually massage and cleanse it actually. Then we can use analyze and visualize, and later on we can publish and collaborate with other people. So that is a Power BI. Yes,
Aroha, can I interrupt
sure,
you for a second? Sorry.
sure.
Are you sharing your slides, PPT slides?
Oh yes.
Because no, we are not able to see. I think you need to share your screen because we are only seeing your video.
Oh
And
sure, 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 sure.
yeah,
My mistake. Let me show you.
yes,
Can you see my screen now?
yes,
I'm so
absolutely.
sorry. Okay, I just okay. Okay. So sorry everyone. So again, so I just recap just 2 minutes. So for us, right, for investment for Power BI, they have a three different audience. The first audience actually is the data scientist who does the lot of coding, lot of coding. They do a lot of things. Then we have another audience which is called as the analyst who does the all the AI models and all. And the last part, which is called as the end users. So today in my demo, I'll be showcasing the all the AI models, mostly targeting towards the end users. Okay. So Power BI, what it does, again, I just want to repeat again so that you can see it. So Power BI is an analytic tool through which you can easily share your screen, modify the screen, and also update your things on the real time as well. So any data, anytime, anywhere. That is the beauty of Power BI. Okay, so we have three different form factors. One is the Power BI desktop, which is you can install on your PC. It's a just like an app which will work today. Second is the Power BI service, which you can is a cloud service, and the last one is a mobile. Okay, so again, so Power BI desktop can do a lot of things. You can churn your data, cleanse the data, publish your data, and also you can collaborate with your end users. Okay. Yeah, so again, just want to emphasize that Power BI desktop is a free tool. I have lot of people have a confusion about which is Power BI. It's free. Yes, Power BI. One of the addition is free, which you can use it for your reporting. Okay, so this is the thing which I want to highlight that Power BI has a free addition through which you can generate the reports, but sharing you can't do it. So sharing you need another version. Okay, so before I show something, I want to show something about Power BI data flow. Now, this is came only last few months back. And what is data flow? Or what is data flow? So data flow is something called as you can have your self preparation, data preparations inside your Power BI service. So Power BI service is a cloud service which I showed you. The second point, the Power BI service, you can extract the data, and is best thing about data flow that you can reuse and as well you can repeat it for multiple services. Okay, so again, I will show you how it works in my demo. So very basically, what is a Power BI data flow? If anyone has seen about the Power BI uh, desktop, have you worked on the Power Query? It's a similar thing, but actually is in the cloud. So in the definition, Power BI data flow is simply a Power Query in the cloud. You can do a lot of amazing fun stuff in Power Query. And the best thing is independent. So you can have a lot of data inside your on the cloud. And why I want to highlight here because data flow, our data flow actually helps you to ingest, transform, and integrate your big data and AI models and all. In Power BI desktop, you can't do it because their data is very, very small size. But if you want to have data flow, you can do a lot of fun stuff and amazing stuff with Power BI machine learning capabilities. Okay, so I will show you what is that. So what is the data flow? Data flow is that mostly you just ingest the data and cleanse the data. And this data actually is always stored into Azure Data Lake. So you can have your data sources here, and you can have your Power BI, which can churn the data, and you have different data services. You can have your Power Platform. You can have using your Azure your Azure services and Dynamics for that matter. So you can use data flow for mostly for all your big data and also for Power Platform. Okay, so one thing very important to highlight here, that I told you that you can have three different versions of Power BI. What first version is free edition. I don't want to talk about that because it's not very useful. It's because it's not secure. The two main versions we talk about is Power BI Pro and Power BI Premium. Okay, one thing to emphasize that the Power BI Premium, a lot of people don't have access because it's very costly. It's around 5,000 USD per month per user. So a lot of customers like me also don't have that particular leverage. But it's very useful for high intensity data, which is you have your sensor to be updated on a regular basis. Then you can use Power BI Premium. Okay. So main thing here is that your storage is for Power BI Pro is always 10 GB per user, but in Power BI Premium is actually its capacity. You have your own server, which is microservice managing it, and you can have around 10 terabyte, 10 TB of data per node. Per node could be your CPUs, and you can increase your RAM. So that is the thing you can do. So it's not about subscription; it's about the capacity, how you can use it. So also there you can do data refresh, and all your machine learning capabilities are actually it's here. You can't do it here in the Power BI desktop, but you can do only in Power BI Premium. I show in my demo as well. Okay. So first thing first, what Microsoft have seen that a lot of people want to use AI capabilities, but because of the premium capability, capacity and the high cost, so Power BI team has created three visuals for the end users. Okay. So first visual is something called as a key influencer visual. So what actually it does actually uses some kind of metrics. So for example, I'm the project manager, and I'm the cloud service provider. And recently, because of the COVID, a lot of people are giving bad feedback, low ratings. So I want to see why people are giving low rating for me. So these kind of things we can do very easily with with these key influential visual, which is again you as an end user or the business user, you don't worry about your AI things. Everything is handled by the this particular visual. So behind the scenes, what it actually using something called as ML.NET, and also using called as one hot encoding and replace missing values. So behind the scenes, using these kind of visuals, but these because this is a some new visuals, there's some limitation as well. So limitation are that you can't directly query from SQL Server, Azure SQL Server, or some kind of a SSLES, you can't do it. And like publish to web, these kind of features are not there. So let me show you my first demo so that you can have a look on that. Priyanka, can you see my screen? Priyanka, can you see my screen?
Yes, Aro, I can see. Yes.
Sure. Thank you. Yeah. So first one, our first visual I'm talking about is something called as key influencer. Okay. So now these are the users. These are all the visuals which all the end users and the power users can use it. So now it is quite small screen. I can see that the key influencer visual is here. And the second visual is a decomposition tree. And the last one we talk about is about the Q&A. So what you can do, you can just do it to, I just remove this thing. Yeah, show you. There's a blank screen now. Okay. So what I can do, I can just go to the insert tab, and insert my key influential visual. Right, it's a very simple visual. It's no rocket science. Anyone can do it. Why I want to show you, because it's something very useful for the end users. Okay, so again, our use case is that I'm the project manager, and I want to see the what's happening about my crowd service. I'm the project manager. I want to see why people giving bad feedback about my service. So first, I want to show you the data set which we have to deal with. Okay, so this is my data set, and go to the data tab, and here I have a my this data set. I have the company size. So we have people from a company size from less than 5,000. Second is 5,000 to 50,000, and the last one is more than 50,000. We have a company size of that. So this table actually have the table for that. Second table we are talking about is a one of most key table, which is about the customer information, the customer ID, the tenures of the person who's staying in that company, maybe 1 year, 19 years, whatever it is, and geography, and the subscription. We have a different table for subscription, and which role they are in, which particular role they are in. But the main thing we are looking for is a rating. Why people are giving role rating or high rating, and the feature, whether is it the design issue or whether the price, whatever it is, right? So we are it's about the customer table. The next table is about the device. So we people can go for whether it's a browser or the tablet or the tablet. Okay, so this is the thing which you are looking for. And we have, the other table is a geography, different continents, which places they are from, whether it's Europe, UK, France, from Asia, India, and China, and North America, which particular countries they are coming from. And the table, I mean, the role is where the user is coming from. Maybe in company we have some publisher. Then we have a mail, the consumer. Consumer are the people who are consuming our cloud service. And we in any company we have administrator who are managing the cloud service. Okay, then we have a subscription. So now subscription could be a basic, premium, or deluxe. Different subscription we have here. And the last one is support tickets. Now you see, this is a very big table. It's around we have around 126,000 records here. Huge table where all details about the customer ID, the customer information, the escalation, everything is here. So this particular customer feedback table, we have to look into this. Okay, so let me show you. So I just drag this particular feature, this particular visual. How I did, I just get the drag this. So what I will do, I just which table we are interested in is the what customer table, where we have to show the rating. So I drag the rating. You see, it shows something, but it doesn't give much value to us, because me as a project manager, we have to get a different dimension, which particular why people from different regions, why they can giving a low ratings. So our target is low rating rather than high. So I just switch to low rating. Okay, and what I will do next, I will try to drag a few of the dimensions. Maybe I go by the region. I will go by a region, and you see when I just drag here, you see a small bulb here. It's very fast, but I think already did it my testing and all. So you see that what me as a project manager, I see that the France is always giving low ratings for us. Okay, so
Aroha, just another request from the live audience. They are asking, can you zoom in a bit the visuals, so that because all the keys are quite
sure. Okay.
small font. So maybe if you are able to zoom in a bit, that would be great.
Yeah, yeah. Is it big enough, Priyanka?
Yeah, yeah, should be okay.
Okay, sorry. Yeah. So I mean, can't see the questions and all. So is it? I think it should be good enough.
Yeah, okay, carry on.
Yeah, yeah.
Sorry. Yeah,
Thank you,
yeah.
Priyanka. Yeah. So thank you. So okay, sorry for that. So main thing here, right? So I just drag one of the dimension that is of the country. Now what I found that uh, country like France is giving a low rating for us. And how I calculate, maybe what I will do, I just how this particular 1.44 things come up. So what I will do, I just go to the this particular France tab. You see that I have a number. Sorry, it's quite small. The number is called as a rating is a 15.01%. 15.01% for France. And if you have something called as an average line, something called as a 10.33. So if you do a simple math, 15.01 divided by 10.33, you get this particular result. So AI always calculate depend on the data points, right? And it actually already calculated that the France and also plotted that is the average. It is the average for this particular France region. Okay, but this is the make doesn't make sense. Let me add some other things so that it make much more simpler. Let me add something called as a user. Okay, and a user. Now you see, after adding the latest highest rating become for low rating is become a consumer, right? So AI always calculate about different dimensions. So if I will click here. So if you see, if a consumer I will click on the consumer. If the low rating is 14.93. However, the Power BI, the AI model also shows that its average is 5.78. So again, if we do a simple math, it's about 2.57 rating. Okay. So what I will do, I'll try to drag more things. Let me add some themes. Okay, you see there's a small bulb. Bulb means it's actually doing some kind of calculation behind the scenes. Okay, so I also do the company size. Do the company size again, running analysis behind the scenes, and I will do some other things as well. I will do the subscription as well. Subscription. You see running analysis. Now you see, now you can easily see that now with the we have added so many factors, and always for all the dimensions, the role is always highest rating is always consumer. But you can tell Aro, even for the administrator is always have a high rating, right? So you can see that as a big bar chart. But the main issue that if for the consumer, the data points, you see data points is around 2,900. But for consumer, administrator is very low. So how we can do it? Let me show something I did here. So the bigger scale here. So let me do something here so that we can, sorry, not this one. I add a new table. Add a new table. What I will do, I'll go to the add a table, add the role, date, yeah, rating. My rating is here. Okay. I also drag the role. Okay. Do by role, and I do again rating. But this time around, I will bump the size so that we can see this. And at this time around, I will increase I will change to, rather than summarize, I will do the count. Now, what you see that for the rating, for the administrator is only 390. However, for the consumer, you see the data points. Data points is 4,373, which means more consumer give low ratings. Low ratings. However, the administrator, because they're part of the company, they never like the product, so they just give a bad rating for the company. But this is the thing we want to highlight, that the AI model always, if you have more data points, better your AI model will be. Okay, this is the one thing. Last thing, I will also show you that what happened if we get the size of the company. Maybe I just change to a filter, right? Now I can change the size. 15. Okay, now you see. Now what I will do, right? If I click on the less than 5,000, the company size, if the company size is less than 5,000 employees, and then I see the filter. If you see the filter, you see, it's always consumer, right? Consumer always giving low ratings. However, if I change to more than 50,000, you see, now security is the key feature. So our AI model actually, if you have a more data points, it will show that the people have a customer who have a more than 50,000 employee size. All the issue is always a security, right? So now we found that, okay, this is so many factors. What I can do, I can just click on the influence, the more key influence. So this is the key influence, which is security, right? This is the key factors. A few of the AI features where the end user and the power user can do it without any writing any code, simple code, something. So it's very simple stuff. So we have this particular tab. Second is the segments. So tell Aro, what is tab about? So this tab is about, you will see the height. You will see the height. This height is the number of people. It's about so the height of the bubble is actually is a low ratings. Okay, when I click the low ratings, these are the low ratings, very low ratings. Okay, okay, so this is the thing. But if I go by, height of the bubble, if I go by height of the bubble, then if we give a different segments, so it give you a different different kind of visual for you, so that you can able to understand. There's the height of the bubble is always about low ratings, but the size of the bubble is the how many customers you have. So in this particular segment, we have around 333 data points. So many customers are here. Okay, and in this particular data segment, we have around 493 customers we have. So this give you a brief information about how the key influencer helped you in your business reports. Okay. So any question? I can't see the visual. So let me move ahead and show you the next visual, which is the decomposition tree. Okay, Priyanka, you can see this my slide deck, right?
Yes, yes, Aroha. Yes, can see. Yes.
Yeah, thank you. Yeah. So the second, this particular tree is one of the most sought after visual which people are looking for. The user voice is one of the most sought after visual they're looking for. So it does now only, I think only a few months back, I think in December 2019, they released it. It was in preview. Now it's in I think in March, make it GA. Generally available. So this one is a very important visual, and what it actually does, similar what we have seen in the some kind of rating kind of things, but now it's about the root cause analysis. So what it does actually look for the multiple dimensions. Same thing in earlier we have different themes, we have different size and all. Same thing we have, but this one is looking for specifically for root cause. So what about in this particular I'll give you the use case later on. But for the what this AI, how this actually use something called as a is drilled down, is using called as a using a matrix to analyze. Okay, and it's using something called as AI splits using high or low value. So in the use case, I'll give you in brief now. So I just close this one because we are not using now. Save it. Okay, and this is the another visual. Now what we are looking for is I am the project manager. Okay, I'm the project manager for the US region. Okay, and this US region, I want to see how many people have actually. I'm going to show this one. How many people have sold for a specific quarter a total revenue for each month for each particular region and which particular product. So you're doing some root cause analysis. So what we can do here, I already created some kind of a measures here, so they can easily, you can view it how it works and all. So our use case is that me as a project manager, I want to get total sales by each state in US, and how many products we have sold for each month, and how many orders we have done so far. So this is the thing we are looking for. This is the second visual we have to work with. So I just drag this one. This is my measure. Okay, this is my key distribution tree. So again, what I will do, I have already created some matrix here to save time. I have just added something called as a sales, total sales. You see now? So now me as a business user or the end users can easily see that I have around 11 million records. You see 11 million records here. But me as a business user or the project manager, I want to see which region has sold the maximum in quarter one. Okay, so I will go here. Okay, I will go and we can increase the size here. Let me check the size. 15. Okay. Okay. So I have an analysis tab, right? Now what I will have to do, I want to see this is a total sales in US. Now me as I have to give this report to my management, my upper management, that how many which state is we have sold the maximum. Now, previously you can't do much because you do a lot of DEX measures to do it. Now, with this particular visual, you can easily do it. How I can do it? By drag the state name. I put the state name. You see a plus button, right? So I can click. And the low or high value. But for me, I have to show the management. I want is the highest value. So I will see. Click here on the high value. You see the California state is always giving high value. It's giving for total sales, California state is giving the highest value. But I also have to factor month-wise, how much we have sold month-wise. So I have something called as, I will drag the month, drag it here. Okay, drag it here. The state, I have month now. Click on the month now. You see a month has come now. Okay, then I will do some other stuff I can do by the order quantity. The ways my order quantity is actually in the sales order. So let me get the order quantity. I put it here. Okay, and the product we have sold. Okay. Now easily. I want to see me the project manager. I want to see in California state and the month of May, how much we have sold for the bridger, and how many products we have sold so far. So now you can see, just by going to the root cause analysis by each state, by each product, I can have a report and I can share it with my management. This is again one of the most important DAX, one of the most important visual which you can do. I have done similar stuff using DAX, and using DAX is very tough to do it. Lot of calculations and nobody can do it. But using this particular visual, you can easily change it. But I can do other things as well. Rather than going to by month, I can go by product as well. You see, now I can go by product and the order quantity, or I just want to go by orders. So maybe for Utah State, how many orders we have done. You see, very easily I can get the total sales. It is 11 million, and the state is Indiana, and we have sold around 47 orders, and these are the sales order things. So it makes much more simpler, much more easier for the for management, even for the business users to check how it works. Right. So, any questions so far? I mean, I can't see the questions here, but Priyanka, any questions so far in that?
No, Aro, you're good to go. People just ask that whether the data set would be available for sharing later on.
Yes, yeah. I'll be sharing the data set. So in my after this session, I will give the data set to Priyanka, and she will share with you. Don't worry on that.
Yeah,
Right?
all right. Yeah, you're good to proceed.
Yeah. So next one is very this one I found is very interesting, where something called as a QA visual. So let me show you the visual here. Yeah. Okay. Uh, Now I'm just assume I'm a business user. I'm the user who have I'm the one who designed. I am Aru Shukla. I designed the entire data set, but my end user, his name is the person. His name is person. He's just doing. He's want to do report, and what he want to do. He want to show to people the total sales. Okay, by item. Okay, so I just will show me total sales. Now I'm the end user, business user. I have no idea about how RO has designed the data set. Okay, I'm the business user. I'm just no idea how my data set is designed. So I go by sales. Okay, so I'm getting the idea. Now I'm getting immediately. I'm getting a record because I'm using a natural language, which is using AI. But I want to do something else. I want to do item. Right? Now you see something, right? Something has become red. Now this user, I want to give a report to the to management tomorrow. And when you click on this item, red icon, you see something. Nothing is showing up. So what he has to do, I mean, that this thing is not visible. So what he will actually message the business user that or the order shopper that this item is not visible. Please help me because I have to give to my management. So me as a designer of the data set, I found okay this particular person is can't find it. So what I will do, sorry, I will just drag the this particular my Q&A. Okay, let me click here and this there's an empty screen. So I will just add because he found that he can't find it. So good thing about this Q&A is that I can easily, I'm as a business user, I know if my data set already know that is a total sales in the West is Gauge. I just click here. I can actually add in my report. You see, it's so easy. Okay, but this is not the use case. My use case is that my business user can't find item. So what I will do, I'll go to Q&A. Okay, I will click on this gear icon. Okay, now this is something new. This is came again. It's in preview. Microsoft is still working on that particular part. But what I can do here, that I go to the review questions. You see this particular requested, right? One of the user could not understand how it works and all. So I know that item is not in my data set. So I just click on data. I click on item. I saw now immediately the Q&A knows that what this item actually refers to. So I know this item doesn't refer to anything. So I have to add some a table so that I can put product description. Okay. Yeah. When you put save it now you can see immediately what my end user is looking for is an item, but me as a report author, I know that this item doesn't exist. So what I can do, I can item refers to product. I can put save it. Okay. And done with that, I also now this is you are teaching the AI. You're teaching the AI that this particular item doesn't exist. So AI next time when this thing item comes, it will actually will tell the business user item actually refers to products. So you see now I have an item here. Just today we are done. So I'm done with this. The main thing here, this I have to publish. I have to publish this report. I have to publish this report so that my end user can see it. I'm going to save it. Okay, I save it. I have already saved my report now. Okay, it takes few seconds to reflect. So let me see whether how much time it takes. Some few seconds, maybe 10-15 seconds. Let me. Publishing, and it will take some time, and later on it will actually show that the item, it takes some time. It may take a few seconds or 1 minute or something. It's not just showing, but actually later after maybe 1 or 2 minutes, data will be shown, and then you can add as many items, any terms you can add there. So that is a few of the visuals which AI has come. I mean, they will add more visuals soon. But this is a thing which I want to highlight that without writing any code and all, you can get these particular BI features, AI features, which are amazingly easy. But if you know the business, you are good to go, right? So I'm going to finish my session here. I'm just waiting for any questions so far. Yes, Priyanka, any question in the? I can't see my screen. I just want to see the YouTube. Okay, so if any other questions, I can just still wait for a few minutes. Any other questions?
Yes, Aro, there was a question regarding the visual which you showed. I'm not sure which visual, but they are asking, yeah, the decomposition visual, whether it was standard or a custom.
Oh no. Okay, it's not custom. Okay, one thing, right? Very important thing to highlight. I'm using the latest version of Power BI desktop. I'm using the latest version of Power BI desktop. Maybe if it's not shown, then you have to go to here and go to operation settings, and then it has some preview features there. This is quite slow. Okay, but this is the standard feature. All what I'm showing you I'm stuck now. So what I'm showing you is all standard visual. It's no custom visual. Even for this Power Apps also, it's actually added now. Only last month they have added. Now it become GA. So all the visual I'm showing you, I'm not showing any custom visual so far. So if you're not, if you're not,
The
yeah,
question is that a part of the desktop? It's the decomposition tree. Is it a part of the desktop?
yes, yes, it's a part of desktop. Yeah.
Okay.
So yeah, it's a part of desktop. Yeah, but if you're not updated your Power BI desktop, then maybe it's a you have to go to the options, and then it has a somewhere it has a preview features there, where you can see the you have to check and then it will be shown to that. But I'm using the August Power BI desktop version, and then it's actually showing in my screen. So if it's not updated, maybe you updated your latest Power BI desktop, then will be shown to that. So Q&A, the key influencer and decomposition tree are already inside Power BI desktop. Any other questions? Yeah, yeah, yeah. So Kazi, yeah. So it's a decomposition tree is part of desktop. No issue with that. So thanks for having me, Setu and Priyanka, for to show to the people the new features of Power BI, AI features, and also it's very great time spending time with you and with the community.
Thank you, Aru. Okay. Thank you so much. Thank you, Aro. Thank you, Eva.
Yeah.
Thank you, Alan. Have a good day.
Thank
Thank
you,
you a lot.
Setu. Thanks a lot.
Bye.
Good
Thanks.
day.